Hi, welcome back to Mrs. Thompson's classroom today. Today's lesson is on angles, in particular some applications of using angles. So let's get started by first talking about decimal degree notation versus degree, minute, and seconds. So oftentimes we name an angle or we describe an angle by its degrees, and we might say 52.65 degrees. Well, that's decimal degree notation. Degree in minutes and seconds breaks it down and lets 1 degree equals 60 minutes and 1 minute equals 60 seconds. That's normal time telling conversions, but now we're going to put it with our degrees around a circle. So our conversions are that there are 60 minutes in 1 degree, or you might write that as 60 minutes in 1 degree. Or we can do 60 seconds in 1 minute. Okay. And so we're going to use these conversions to change back and forth between the notations. So if we have 25.34 degrees, the 25 is the whole number of degrees and it sits there. But we need to take the 0.34 and convert to minutes. Okay, so there are 60 minutes in 1 degree. So we're going to take 0.34 and multiply by 60, and we get 20.4. Okay, so far we have 25 degrees and 20 minutes. And now we're going to take this 0.4, which is in minutes, and we're going to go, okay, there are 60 seconds in 1 minute. So now I multiply that by 60, and I get 24. So my final answer would be 25 degrees, 20 minutes, and 24 seconds. Okay. Now we can convert the other direction. So let's start here with the seconds. If I have 25 seconds, there are 60 seconds in 1 minute. And then there are 60 minutes in 1 degree. So to get that 25 seconds into degrees, I'm going to divide by 60 twice, and I get 0.00694. Okay, then I'm going to take the 15 minutes and I'm going to convert it. So there are 60 minutes in 1 degree, so the minutes go away. And when I do the calculation, 15 divided by 60, I get 0.25 degrees. And now we take 30 plus 0.00694 plus 0.25, and we get 30.25, and we'll round it off to 3 decimal places. Will be enough accuracy. So we can go back and forth between the 2 notations. Now, most of the time we're going to use the decimal degree notation. But you do see the degree, minute, second notation used in regards to map reading. With latitude and longitude, they'll talk about minutes and seconds. Okay. All right. There's another application, and that is linear speed and angular speed. So linear speed is how far in a straight line you're moving. Okay, so if an object is moving, how far forward and backwards or up and down. Angular speed is how fast something is going around a circle. So when you're talking like a bike tire or a car tire and how fast it's rotating, that would be its angular speed. Now the 2 of them are related. So this Greek letter here is angular speed, and it is related to the linear speed by dividing by the radius of the circle, the wheel, whatever thing we're going around. So let's take a look at this example. A plane is in a circling pattern over the airport. It flies in a circle with a diameter of 50 miles. So here's my plane, okay, flying around a circle. The diameter of the circle is 50. That would mean the radius is 25, okay. It makes 1.1 revolutions per minute. Okay, in order to get this to angular speed, I need to get rid of revolutions and get to radians. Well, how many radians does it take if the plane makes one circle? Well, one revolution is going to be 2 pi radians. So I can do that conversion by saying 1 revolution, so that makes this go away, equals 2 pi. And when I take 0.1 and I multiply by 2 pi, I get 0.628. So this is my angular speed. Okay. Now it says to also find the linear speed. Well, linear speed is distance times time. You also notice that it is related to the angular speed this way. So the 0.628 is going to equal our velocity divided by our radius. That means the linear speed of the plane is going to be 0.628 times 25, and that gives us 15.7. The 25 is in miles, and we are in minutes on our time. And so this would be our linear speed. Okay. Our next application, and our last one of the day, is arc length and area of sectors. So let's take this circle and mark its radius. And we're going to go some angle around the circle. The arc length is this distance here. And they like to use an S for arc length. So let's see if we can figure out what S is. Well, we know that the circumference of the circle is 2 pi times radius. That's the whole circle. But I only want this piece of the circle. So the arc length is going to equal that circumference. And then we're going to take just the piece of the circle that we want and divide it by 360 if we're in degrees. And so that equals pi times r times theta over 180. Or if we are in radians, we'll have 2 pi r times theta over 2 pi if we're in radians. And so that's going to equal just r times theta. Okay. So this is arc length. Now what happens when we talk about the area of a sector? Well, again, here's our radius. We're going to make some angle. The sector is this piece of the pie. Okay, so the area of the entire circle from geometry we know is pi times radius squared. the area of the sector then is going to equal that pi r squared times whatever portion of the circle we're making. Depending on when we want to be in degrees or in radians. Now notice on this bottom one, the pi's do cancel, and I end up with r squared theta divided by 2. So you might see it written like this. Okay, so let's do an example. Let's find the arc length, the length of the arc intercepted by a 125-degree angle. So, and we have a radius of 12. So the arc length, which we'll let be S, is going to be my circumference. Okay, that's circumference times the fraction of the circle that I want, which would be 125 over 360. So when I multiply this all out, I get 2 times 12 times 125, and I'm going to divide that by 360, and I'm going to leave it as a fraction, and so I get 25 thirds pi. And this will be in inches. If you want to get it as a decimal, multiplying by that pi gets 26.180 inches. Okay, now we can also find the area of the sector. The area is pi times radius squared times the fraction of the circle that I want. So I'm going to do 12 squared times 125 divided by 360, and I end up with 50 pi. That would be approximately 157.080 inches squared, because now this is an area. Okay, now we can go the other direction. Let's say they want us to find the radius of the circle with a central angle of pi thirds that has an arc length of 15. So arc length, again, is 2 pi r times my angle, and since this is in radians, and I know that because it has that pi in it, and it does not have a degree symbol mainly, so I'm going to put a 2 pi on the bottom. So the 2 pi's go away, and I end up with the arc length of 15 equals my radius times my angle. And so if I solve for r, I end up getting 3 times 15 over pi. So that's 45 over pi. And if you want the decimal approximation, you'd get 14.324. Okay, and this is in inches. Now, generally speaking, we're going to leave our answers precise. So I'm going to leave it just as that 45 over pi, unless I have to use that number for some other purpose. Okay. All right, one last example. We've got 2 cities on a globe. So it says that B is due north of A. So here's city B, and here's city A. And I want to find the distance between them. So really what I'm doing is I'm trying to find this arc length. Okay? So the first thing I need to do is I need to know the radius of the Earth. Well, here's R. So arc length is 2 pi r times the angle divided by 360 degrees, because I'm going to be in degrees here. So my radius is 3959 approximately. So the question is, what is the angle between them? What is the angle here? Well, I know where each of them are at. So the angle is going to be 35 degrees, 15 minutes, minus 28 degrees, 50 minutes. So you can do the subtraction this way, but in order to do this calculation, really I want it as a decimal. So let's convert these. This will be 35 plus 15 minutes times 60 minutes in 1 degree. So that's going to be 35.25. This one will be 28 plus 50 minutes times 1 degree equals 60 minutes. So that's going to be 28 point, let's see, 50 divided by 60, going to give me 0.83 repeating. So when I subtract those two, I get 6.417. So this is my angle. So this goes here. And then I do this calculation. So I'm going to do 2 times pi times 3959 times 6.417 divided by 360. And I get a distance of 443.399 miles apart. So we can find distances between cities by using their latitudes or longitudes if they are directly north and south or directly east and west of each other. Okay? All right, so hopefully that all makes sense. Let me know in the comments below if you have any questions or when you come to class today. And we will see you next time.